Hello everyone. This tutorial is regarding our module 2, which is the predisol, which is the predictive analysis software. So I'll quickly get going. So once I open our software, we get the following user interface. I'll click on predisol, and what I get is this. So this is just a demo version. Okay. Now. So this predictive analysis module, predisol, it can literally predict anything for you. You just need to import the training data. The system trains itself according to the training data and gives you the output or predicts what you want to know. So basically what happens is you can train anything like text or data points which you have or image or anything. All you have to do is import the training data. It's as simple as that. So right now the software is calibrated for text, image, and data points. So for this example, because of time constraints, I'll use uh, data points example. So what I have is this data set. So this is data regarding electrocardiogram. These are some variables which I don't know really what these variable mean. This is just downloaded from the internet, and but what I mean is, what I know is this is data regarding ECG reports of the patient. So this is already available, and based on this, the doctors have actually classified the patient into three classes: 1, 2, and 3. And so basically, 1 here means the patient is normal, 2 means the patient is in moderate or moderately severe condition, and 3 means the patient is very severe. So this is how the classification has been done. So what we want to achieve here is we want to predict this, like given any data point, given any new data point or new ECG report, I want to know automatically whether my patient is categorized into 1, 2, or 3. Which category is he? Normal, is he moderately severe, or is he very severe? So this can have applications in eye care as well. For example, suppose I have data regarding the size of the optic disc and some other parameters regarding the patient, and I know I train the system that whether the patient is suffering from glaucoma or not. So what will happen is, once the system is trained, given any new patient, if you have the fundus image or if you have the size disc, you can actually predict whether the patient is suffering from glaucoma or not automatically in your outreach centers or in your eye camps. You don't need a specialized intervention of a doctor, or so this is just this can be a great assistive technology. And then some other test case could be, for example, if I have a fundus image and I want to predict whether the patient is suffering from diabetic retinopathy or glaucoma or anything. So this could be one case of image processing. So what happens is, right now existing softwares only do image processing or only do data processing, but our software can take into account both. For example, you have the fundus image as well, and you have several other parameters like BMI of patient, or his previous history, etc. So our software takes into account everything, including the image, and then will give you the exact probability that whether the person is suffering from this disease with certain probability or that disease with certain probability. So basically this system, this algorithm is actually more robust in this case. So we'll get going with this. So this is the training data which I have. Okay, so one more test case in eye care could be, suppose I want to predict, given a patient, I want to predict after a surgery what could be the possible refractive errors he might face at a certain period of time. So if I'm already aware that a particular patient X will face this refractive error with certain probability, it can help me intervene properly, and so it will actually lead to improvement in the quality of care which you are providing. So basically these are some test cases. You can predict anything that comes to your mind. So this, let's get going with this. I have imported the test data here. So then what happens is, So our algorithm has, so our code, our software has several algorithms in place. Now what happens is, uh, a particular algorithm will go well with only one data set. Like for example, for this data set, there is one particular algorithm which goes very well and which gives very high accuracy. But there are other algorithms which may not work very good with this data set. So this thing actually requires a prior knowledge of machine learning and artificial intelligence and all these algorithms, because given a data set I have to customize the algorithms accordingly. So for this data set I cannot use all the algorithms which are available. There are only certain set of algorithms which can be used, and also in that certain set of algorithms there may be only one or two algorithms which will give the best accuracy. So we have to find out that. So but I don't expect that the users will have a very good prior knowledge of artificial intelligence and all. So that's not an issue, because our software does not require you to have prior knowledge of anything. So what we have here with us is this algorithm assist. So what this does is, once you click on algorithm assist, there is a whole machine learning algorithm running in the background for this. What it does is it reads your training data, whatever you have imported. It tries to understand what you want to achieve, what you want to predict, how your training data is, how your data set is, what are the types of variables, what are the type of the target variable, there are how many target variable. All those things happen in the background. You just have to answer certain simple questions on what you want to achieve, what is your target, or what is your objective, what kind of predictions do you want. So those are some simple basic questions you have to answer, and to this algorithm assistant there's a whole machine learning. It learns how your data set is, and then it comes out with a prediction, or then it comes out with a suggestion basically of which algorithm to use. So I'm not showing algorithm assist right now because of time constraints. It takes some time to run. So by running algorithm assist, what we got is we need to use algorithm number 4 for this data set. So let me calibrate this. So I'll also show you one more thing. So for the sake of this tutorial, I have kept this algorithm compare button outside the algorithm assist. Actually, this button is a part of algorithm assist. So what it does is, suppose there are 10 algorithms in my software. So these 10 algorithms may be best suited for some data sets. Okay. Now once I have imported the dataset and I've clicked on algorithm assist, the algorithm assist will first try to understand how your problem is, try to understand your dataset, and try to learn. And then the algorithm assist will actually tell you, for example, of 10 algorithms I can use only 4, 5, 6, 7. Okay. Now for the 4, 5, 6, 7, I don't, so maybe fourth algorithm will give me a 90% accuracy, fifth algorithm will give me a 96% accuracy, because the accuracy of the algorithm will actually depend on the dataset. So what this algorithm compare will do is, this algorithm compare will take a sample from your data set, and it will compare like which algorithm will give the best accuracy. So for example, in this case algorithm 4 was giving the best accuracy, so algorithm assist will actually come up with a suggestion that you can use algorithm 4. So suppose you don't want to use algorithm 4, by using algorithm assist now you know that you can use 4, 5, 6, 7. So you can use any of these, or if you want the best accuracy you can use algorithm 4. So all these hustle and bustle is done by the algorithm assistant. It will just tell you what algorithm you need to use. So here I'm using algorithm 4. So I'll also show what is algorithm compare do. So once I click here, I'll print this course on my console. So the code or my software is right now comparing what are the possible algorithms that I can use, and what are their accuracies. So once this is done, so you get actually the accuracy scores of different algorithms. So for example, maybe algorithm 4 is giving you 99% accuracy, algorithm 3 will give you maybe 90% accuracy, something like that. So once this is done, so these are the inbuilt tree settings. So what happens here is uh, these settings you can always adjust. Okay, so for example, these settings are something which is needed for the software to run. So you don't need to play around with this. These are already set to default. Like I can always change these values, but these are already set to optimum default, and we don't really have to change this. But there is an option of changing this also. For example, what happens is if I change these values, what will happen is I may get a better accuracy, or I may get a accuracy which is worse than the present value. So playing around with these values will actually play around with the accuracy. Okay, so right now these values are already set to the default optimum, and uh, but for research purposes, if you want to see the sensitivity of these parameters, how changing these parameters will lead to a changed accuracy, we have this advanced evaluation option. So once you click on this, you actually get a graph of the tree count versus accuracy. So basis that graph, you can choose what is the optimum number of tree count you need to use. So what happens is actually, suppose by advanced evaluation I get the optimum number of tree count for this problem, maybe 300, which means that with 300 tree counts also I can get the accuracy. I can get that much amount of accuracy that I'm getting with the 500 number tree count. So I can reduce the number then to 300, and then my computation time will reduce. But this will just lead to more complexity. So right now we are not discussing this. Right now these are already set to optimum, so these optimum numbers can actually solve any problem. So with a fair bit of accuracy, more than 95%. So that's not an issue here, so we can just skip this part. So okay, now clicking on algorithm compare. So it took some time to run, because like I said, algorithm assist also takes some time to run. So algorithm assist takes about 5-6 minutes to learn and then suggest you. So that's so right now. So that time I have clicked, and we are getting the results now. So we can see I am printing this on my console, which is the command prompt here. But since this is a demo version, but in the actual version we have it in a log file here, which you can see. So here we can see algorithm 1 gives you 94 or 95% accuracy, 2 also gives you 95, 3 gives you 90, 4, which is suggested by algorithm assist, will give you 99% accuracy, and 5 only 90. So that's where algorithm assist comes in very handy, like 99% accuracy, and these are 94. So algorithm 4 is best suited for this data set. So that's why we have been using algorithm 4. Okay, so so what we have done, we have imported the data, we have used algorithm assist to predict what algorithm to use. We are using this algorithm. These settings are already set to optimum. We don't need to play around with this. These are only for research purposes, or if I want to understand how playing around with these will lead to a lower computation time, etc. These are already the default values. You don't need to change. We have seen algorithm compare. Now what comes is we need to test the data set. I mean, I need to predict for the new values. So here I import my new values for which I need to predict. So I'll first import, and then I'll show you. So this is the import, and the test is this. So yeah, so this is my testing data set. So basically it has all the values of the CG which we have seen. These are the variables which are available to me, and now I want to predict this value NSP, which is blank here. So actually I already have the values of NSP. So these are the actual values which my code should predict. I mean, this is the actual value of NSP as given by the doctor. But in order to test the accuracy of my system, so I'll remove these values and I'll see what my software actually predicts. So I'm deleting this, and click on save. So let's run the code and check. So once I click on evaluate, the code will run in the background. So it takes some time again because this is a very large data set. So I already have a sample file here. So algorithm 4 was weighted gain and algorithm. So the file name is this. We can always change the file name. So this is what we get. So here what happens is these are the known variables of the ECG that we already know, and so these are the actual values. I mean, I have given it the name predict here before. Let me change it to NSP. So these are the actual values of NSP which the doctor has classified, and these are the predicted values of NSP which our software is predicting. So we can see there is a significant match here. Predicted value is 2, NSP value is also 2, or the actual value is also 2. Predicted value is 1, actual value 1. Predicted value here also 1, 1, 3, 3. So since the code is 99% accurate, there are very few, 1 or 2 mismatches maybe, but mostly the code is or the algorithm is accurate and predicting the correct values. So this was just one simple example of what you can do. So this data set had all numeric data inputs. But what happens is sometimes you may have textual inputs as well, you may have image inputs as well. So not an issue for that as well. All you need to do is you need to train the system accordingly. You need to have the data set accordingly, whatever it is, be it image, data, text. You need to input the data set. You need to use the algorithm assist to understand it and tell you what algorithm is best suited for your data set, and you can either choose that algorithm, or you can go you have the freedom to choose any other algorithm as well. So you choose the algorithm, and then you import what new data you want to predict, and then you evaluate and you get the result. And these inbuilt settings are by default set, so you don't need to play around with this. Playing around, if you want to play around, you can go for advanced evaluations where you have full freedom. You can change these values, and you can see how the accuracy changes. So that's all for this video. Thank you so much.